Let's look at a couple of popular protocols and how those fit into the OSI model that we looked at previously. Specifically, we're going to look at IP and ICMP, which both dwell at the network layer. IP stands for Internet Protocol and ICMP stands for Internet Control Message Protocol. With IP, that carries some upper layer protocols on top of it, such as UDP, User Datagram Protocol, and TCP, Transmission Control Protocol. Both TCP and UDP, as we discussed in a previous video, live at the next layer up in the OSI model, which is the transport layer. And what IP can do is it can essentially wrap up those layer protocols and send them across a network inside of an IP packet. And that's what we refer to as encapsulation. When we looked at IP addressing earlier, that's what this is used for. This might be using IP version 4 or IP version 6, and we use that to transport our upper layer protocols. One common piece of hardware that operates in the network layer is a router. The network layer, remember, is layer 3 of our OSI model. So routers make packet forwarding decisions based on a layer 3 address. In other words, an IP address. Also at layer 3, we have the Internet Control Message Protocol, or ICMP. The most common use of ICMP is with the ping command, something that you may have used before. A ping lets us see if our network device has reachability to other network device, which could be on our local network or that could be out on the internet, maybe a web server. As an example, take a look at this very basic topology. We have a PC connected into a layer 2 switch, which is then connected into a layer 3 router. Now, layer 2 switches make forwarding decisions based on physical MAC addressing instead of IP addressing. So switches, a layer 2 switch specifically, will operate at layer 2 or the data link layer. The router, as we said, makes decisions based on layer 3 IP addressing. Let's assume that our PC has no internet connectivity for some reason. We open our browser, nothing seems to be loading, we can't get out to any websites. One of the first things we might want to troubleshoot is to attempt to reach our default gateway. In this topology, that would be our router, and we would try and test that reachability using an ICMP ping. The router gets us out to the internet, so it is acting as our default gateway. The way this works is that our PC will first send an ICMP echo request out to the router's IP address. In my network, we'll test this out in just a bit so you see how it works. My local default gateway IP address is 192.168.0.1. That's on my virtual network that I'm using in the lab. If the router successfully receives the message, it's going to send back an ICMP echo reply back to the PC, letting the PC know that the router did receive the initial ICMP packet. When the PC receives that, it's going to return a message back to us in the terminal or the command line or wherever we are issuing our ping command, and it's going to let us know that this attempt was successful. It's also going to display other metrics such as the round trip time it took for the ICMP process to complete, which will help give us a good idea about any delay that we might have in the network between maybe our PC and the gateway. So if we have a high amount of delay here or latency, that could indicate that there's an issue somewhere in the network between our PC and between the gateway. Now let me show you what this looks like from my Kali Linux instance. Let's jump over to that, and I'm going to ping my default gateway. To do this, I'll type ping 192.168.0.1 and then hit enter. And you can see that we're receiving success messages back. I'm going to use Ctrl+Z to interrupt that process. Hence, we're seeing those success messages, which means we're all good. You can see that these are 64 bytes. That's the size of those messages. We see where our ICMP echo reply came from, which is of course my default gateway 192.168.0.1. We see the reference to the ICMP protocol here, and we see the sequence numbers that sequentially go higher as each one of these attempts are made. And we see the round trip time. And it looks like the round trip time in this case is around a half a millisecond on an average. And that's because my virtual machine is on my local network. So that time will vary depending on the topology that you're using and the size of your network, or where the destination host resides. In my case, it's pretty low, and that's to be expected. Although we had looked at IP addressing earlier, I thought it would be good to explain exactly what IP is and also look at ICMP. Both of these being the most popular protocols that you're going to use day to day as you progress with general networking and pen testing.